Let's look at composition of functions. For example, let f of x equal negative x minus 1 and g of x equal 2x squared minus 2. Let's find f composed with g evaluated at negative 2 and g composed with f evaluated at negative 3. This function here is called the composition of f with g, and is defined as follows. F composed with g of x is equal to f evaluated at g of x. That is, we plug in g of x as the input to this outside function here. And be careful here, this is different than f of x times g of x. This is not equal to this. And similarly, this function here is the composition of g with f. And g composed with f of x is defined to be g evaluated at f of x. That is, f of x is the input to this function g. All right, so let's compute our two values here that we're looking for. F composed with g of negative 2 is equal to f of g of negative 2. So what is g of negative 2? Well, looking back up here, that means we have to plug in a negative 2 wherever we see an x. That is, g of negative 2 is equal to 2 times negative 2 quantity squared minus 2, which is equal to 2 times positive 4, which is 8, minus 2, or 6. Which we then plug in here and evaluate f at 6. That is, this is equal to f of 6. And looking up here at our function f, we're going to plug 6 in wherever we see an x. That is, this is equal to negative 6 minus 1, or negative 7. All right, and what about the second value we're looking for? G composed with f evaluated at negative 3 is g of f of negative 3. And now we first need to compute f of negative 3 by plugging in negative 3 up over here wherever we see an x. That is, f of negative 3 is equal to negative 3, be careful, minus 1, or 3 minus 1, which is 2. And this is what we plug in here and evaluate g at. That is, this is equal to g of 2. And looking back up here at g, we're going to plug 2 in here. That is, this is equal to 2 times 2 squared minus 2, or 2 times 4, which is 8, minus 2, which is 6. So this is our other value. Let's look at another example. Let u of x equal x squared plus 4 and w of x equal the square root of x plus 3. Let's find u composed with w of 3 as well as w composed with u of 3. Again, u composed with w at any x is defined to be u evaluated at w of x. And w composed with u of x is defined to be w of u of x. So looking up here at these values we're looking for, we're going to be plugging in 3 wherever we see an x in both of these. That is, u composed with w of 3 is equal to u of w of 3. And what is w of 3? Looking up here at w, we're going to be plugging in a 3 wherever we see the x, which gives us that w of 3 is equal to the square root of 3 plus 3, or the square root of 6, which is what we're going to plug in here and evaluate u at. That is, this is equal to u of the square root of 6. So we need to evaluate u at this square root of 6. And looking back up here at u, we need to plug square root of 6 in here, which gives us the square root of 6 squared plus 4, or 6 plus 4, which is 10, which is the first value we're looking for. All right, and what about w composed with u of 3? This is equal to w of u of 3. And what is u evaluated at 3? Looking back up here, we need to plug 3 in wherever we see an x. That is, u evaluated at 3 is equal to 3 squared plus 4, which is equal to 3 squared is 9, and 9 plus 4 is 13. So we're going to plug that in here. And therefore, this is equal to w evaluated at 13. And to evaluate w at 13 means looking back up here, we have to plug in 13 wherever we see an x. That is, this is equal to the square root of 13 plus 3, which is equal to the square root of 16, which is 4. So this is the second value we were looking for. Now notice something here. This was u composed with w of 3, and this is w composed with u of 3. Notice they're not equal to each other. Even though the inputs, namely 3, to these functions are the same, the values are not the same. However, there is a special situation in which these values will be equal for any input. But we'll learn about that in the inverse function lessons. All right, and this is how we work with compositions. Thank you, and we'll see you next time.